Okay, this is going to be a recording for Thursday, the 10th of January, and it is notes on 4-7. Yes, it is. Okay, so what we're doing today is looking at inverse trig functions, and we're starting by focusing on sine. If you remember that table that we need to be able to generate, we'll be generating it today as well. And I just left it at this slide a moment just to kind of remind you, oops, that that when we have, and I'm just having a little trouble pushing that up a little bit. There we go. When we have the arc sine or the inverse sine, it's going to be the arc sine or the inverse sine of the ratio, and then we're giving the angle. So when we use that same table that we're used to using, or that same chart, we're used to looking at the angle and going across to find what that ratio is. Now we're going to know the ratio and we're going to find the angle that way. It will always give us a reference angle, and then we'll have to find the actual angle as we go. We also said that because sine oscillates, we have to restrict the values of the angles that we can use, and we get all the different values if we go from negative pi over 2 to positive pi over 2. So if we graph this, and we'll just look at the graph to begin with, and then in a little bit we'll also graph the arc sine. So you don't have to feel like you have to graph it exactly right now. And here is what is happening. And if you think a moment, and right now I'm just going to do kind of 2 lines of a sine chart. If we want the sine of theta and we want our angles in radians, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Sine is that, first trig function, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So it's just like any inverse function. When we're finding an inverse, we interchange x and y. So where before this was x and this was y, in y equals sine x, in order to do the inverse, we interchange x and y. So x equals the sine of y, so to speak. And so then we say that the arc sine of x is equal to y. And so that's kind of the sequencing that we're doing. So when we graph this, our x-axis now goes from, in the table here, from 0 to 1, but we know our full values for trig functions go from -1 to +1, and then our y-axis goes from negative pi over 2 to pi over 2. And so here's a couple of easy key points to think about graphing, and we'll graph this later if you want to just kind of sketch this or not right now. One easy point to graph is the point 0, 0, and then when the sine is 1, when the angle is pi over 2. And we also know from our graphing and using these points that is a different coordinate axis. This is a unit circle coordinate axis, and so we know that when we're down here, this point would be 0, -1, and this is the cosine theta comma sine theta. And so the angle that we're using in this other alternate axis using a unit circle, that angle is negative pi over 2. So at negative pi over 2, we get the sign of negative pi over 2 is negative 1. So when we invert those, we're at negative 1 when we're at negative pi over 2. And the rest of the angles are there as well. It's kind of this trig function. It looks a little maybe stretched out just by the book author values that they're using there. But we will be kind of looking at that a little bit in more detail as we move through. We focus super a lot on the inverse sine, and then we just kind of add all the rest in as we go through this. By the way, let me just make this statement right now because I am kind of thinking ahead to the test. When you do inverse trig functions, you only use radians. Okay, so when you do inverse trig functions, you only use radians. And so just kind of keep that in mind as you're doing this. So if you prefer to use degrees, make sure you always convert things to radians as you go. So the definition of the inverse sine function is defined to be y equals the arc sine of x, if and only if the sine of y equals x. And then it gives a lot of other information, and I'm going to add some things here as well. That says where negative 1 is less than x, which is less than 1, and negative pi over 2 is less than y, which is less than pi over 2. So what that means to me in this inverse function, the domain goes from negative 1 to 1, including both of those. And the range goes from negative pi over 2 to pi over 2, including both of those. And there's a couple of really important things to keep in mind. So when we were doing regular trig functions, the angle could be any real number, correct? You know, any real number, and we could find the sine of that or the cosine of that. It may or may not be on the chart. But now our domain just oscillates between that negative 1 and positive 1. So you will have instances where they'll say things like, what's the arc sine of negative 5? And there isn't one, right? Because you can't get to negative 5. So just kind of keep that in mind. So I'll maybe even write something like the arc sine of negative 5 does not exist. Does not exist. Because this number has to be between negative 1 and positive 1. If it's some decimal, you're good to go. But if it's not, then you have to be careful of that. The only other thing I'll just kind of comment on is because sine is defined at negative pi over 2 and pi over 2, they're included. When we do tangent later on, it has asymptotes at the endpoints, so those will be undefined. So right now, you know, it's not really something that that we'll be using. Many answers can be given as exact answers, and that means that they'll fall on that table. So anything that would have a reference angle of pi over 2, pi over 3, pi over 4, pi over 6, or 0. I don't know why I went that way. But any of those reference angles will be able to kind of have a value as we go. So just a reminder from before, if we had the angle theta and sine theta, and I'll just write that piece of the chart, 0, pi over 6, pi over 4, pi over 3, and pi over 2, and 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1, where that was the chart that we used before. Now this is going to be our y, and this is going to be our x. Okay, so the values that we start with are going to be those ratios, and then since we're just using arc sine right now, we'll look at that and find our reference angle from here, and then our actual angle from that table of values. So then back to the actual angle, and I know there was some confusion on this, so let me try to be just a little more clear. This little axis, we're not actually using it to graph anything. This is how we decide, all students take calculus, kind of where we're dealing with things. So because this this is defined with a range from negative pi over 2 to pi over 2. When we are doing the arc sine, we never use these two quadrants. Okay, so we do not use these two quadrants later on, and so when we do this and when we add the rest, there's always just two quadrants that we're using, because remember, we're not allowed to have repeated values. We only get one value. And so in addition to this, keep in mind that at negative pi over 2, we have this point, which is 0, negative 1, and at pi over 2, we have this point, which is 0, 1. And so all of our values will be between here and here. The nice thing about the sine functions is if the ratio is positive, boom, it's right there. If the ratio is negative, it's the angle off the chart, but it's just the negative angle. So it's very, once you find the reference angle, you're going to know the answer. It's either the positive angle of that or the negative angle of that. So let's just kind of put a little example as we go. Let's do the arc sine. So if I want the arc sine of the square root of 3 over 2, and I'll just put a blank there for now. And then if I also wanted, as a separate question, the arc sine of the negative square root of 3 over 2. These are both, once I can answer one, I can answer the other. So we're doing this kind of backwards thing where I look for, since our function is sine, it's the arc sine, but it's related to sine, I look for the square root of 3 over 2. What's the reference angle? Pi over 3. And if it's positive, it'll just be in that first quadrant. So my answer is pi over 3. And that reference angle is pi over 3. And the book authors call that theta prime. I tend not to use that because it's just too close to theta. So I just call it the reference angle. So then when we do the arc sine of a negative number, then I just look up here for the square root of 3 over 2. And so the reference angle is still pi over 3, correct? But because we're only allowed to use these two quadrants, I will go negative. The reference angle is still the square root of 3 over 2, but because it's going to be down here where sine is negative, correct? So sine is positive there, sine is negative here, then it's just going to be negative pi over 3. So that's the nice thing about starting with sine, is once we figure out what the reference angle is, if there's an exact value, then if the ratio was positive, it's just going to be that's the answer. If the ratio is negative, it's just going to be the negative angle that's there. Occasionally, we'll have to use a calculator, but most often the ratios will be right on our trig table, and we'll be able to kind of get those as we go. So I don't know if I hope I'm not doing too many things with my smartboard right now, but I'm going to try to take a picture of this little piece of table and this. So I don't really care about that other thing, and that's enough table. Ooh. Very loud in my own personal ears. So I'm going to make this kind of like super small because I just want to be able to see it. And I'm going to cut it out of here. Okay, so now our job is to find, if possible, find exact values, okay? So there's two reasons it says if possible. If it doesn't fall within our domain, it's not possible. And if it doesn't fall on our table, we can't get an exact value, correct? So our goal is to see if we can find things that are on our table. I'll just have my own little, piece of table here as I look at it. And I want to go through this, very, very straightforward so that, anytime we're doing one of these, once we start doing other rules, we know that, we're always setting this up the same way. So the first thing is because it's arc sine, And later we'll know, what quadrants to block out. If it's arc sine, we want to immediately block out those two quadrants because we're not using any values in those two quadrants. So that's your first job. Your second job is to look at the ratio that is here and see if you can find it on the table and get a reference angle. So we don't care for this moment that it's negative a half, but our reference angle for the sine of theta equals 1/2, so our reference angle is pi over 6. And then, I'll maybe use a different color just to kind of see. Then I'm going to say, okay, because it's negative a half, this is quadrant 1 is where all trig functions are positive, and this is the sine is a negative ratio, and in the fourth quadrant cosine is the only thing positive. So we're not going to use that one. I can now block that one out. I'm using a different color so we know it wasn't the original. And so that means my angle is down here, and it's going to be that negative angle because that's all I can use is a positive or a negative angle. So then I can give my answer as the arc sine of negative 1/2 is equal to negative pi over 6 because I have to go from there kind of down as we look at that. So let's just kind of, stay with kind of doing these together. I'm going to skip that one for a minute and because I think it's a little easier. So we'll come back to B. We'll do these kind of together. I wonder if I can just do this. Let's see. Yeah, awesome. So then I'll look at the arc sine of -2. All students take calculus or excuse me, the inverse sine of 2. My bad. The inverse sine of 2. So what is the angle that's going to be matched with that? Okay, what is the domain of this? What is our domain? We just wrote it down. -1 to 1. So our domain is from -1 to 1. So if they're calling for the inverse sine of 2, can we find an angle that will work? So this one is not possible. And so there is no value, and you will encounter that, so do be kind of aware of that. So the next one is arc sine of 1. All students take calculus. We kind of, we're only doing arc sine right at the moment. So the arc sine of 1 is here, and it's positive, so that means that I can kind of get rid of that. What is my reference angle? Our reference angle is pi over 2. The 1 is on there. Pi over 2 is the angle that we use. So our reference angle is pi over 2. We've already blocked this out, but just to kind of validate that and remind ourselves of what we've done before, that point is 0, 1. And so that is going to be the positive pi over 2. So the arc sine of 1 is equal to positive pi over 2. So now we're going to go back to this B problem. And so you take a moment and figure out what that is. And I'll come and look at your answer so you can point to it for me. Yes, B. Yep. the table. Okay. Okay, so let me just go through this one, and next time I will try to pause it. So, uh, and all students take calculus. We know it's the arc sign or the inverse sign, so we're not using those two quadrants. We know that the ratio is, and I'll maybe just paste it again right here. We know that the ratio from our table of values is the square root of 3 over 2. So our reference angle is pi over 3. We know it's positive pi over 3, so we're not going to be using that quadrant. It's going to be right up here. So, you know, I can also kind of think I'm always, where is my initial side and terminal side? And am I going to have a positive or negative angle? And so since it is positive, it will be positive pi over 3 as we go. So the next thing we're going to do is just have our good sketch of the arc sign, and then we'll actually look at the inverse cosine or the arc cosine and the arc tangent. Because once we get the idea of one of these, we should be able to do all of them. The difference being that, well, because we're looking at the picture, the table, we get that ratio, and then we get the reference angle, and then we decide from here what that answer is. And the thing to just be aware of is when we do the other trig functions, we won't always be using these same two quadrants. So sine is actually kind of one of the easiest ones to kind of do as we go through. And this is just that same thing. Now, what we're going to do is we're going to sketch a graph of y equals the arc sine of x. And we're going to start by making a table of values, and we'll do this for the arc sign as we go. You might want to be thinking about that table. Oh, I'm just really liking pasting this little piece of table that I made up here. Just so happy. And so what we're going to do is we're going to graph these positive angles, and then we're going to graph the negative ones as well. And so I might need a little technical support to get some values. And we're going to remember that this is the inverse sign, so x is going to be the ratio from -1 to 1, and y is going to be the arc sign or the inverse sign. The inverse sign of x is going to be what y is. So I'm going to go from, and I am going to do it, even though I'm doing it with the value and then the angle on the bottom. I'm going to put the angles in first, the y angles. So we're going to go from negative pi over 2, and I'm just going to work myself backwards there. Negative pi over 3, negative pi over 4, negative pi over 6, then 0, and then just back the other way. Pi over 6, pi over 4, pi over 3, and pi over 2. So that's actually going to give me quite a few angles to plot there. And my y values are going to be my angles as I go. And then right now I'm just going to write the exact value, and then we'll figure out kind of what the close decimal is. So at negative pi over 2, I'm down here. So the sign of negative pi over 2 is -1. So these are essentially just the negative values. At pi over 3, it's negative square root of 3 over 2. At negative pi over 4, it's negative square root of 2 over 2. At negative pi over 6, it's 1/2. I'm just going to put it as 0.5 right now because I'll be plotting it. At 0, it's 0, and then I'll just put those as positive. At pi over 6, it's 0.5. Pi over 4, it's square root of 2 over 2. Then square root of 3 over 2, and then positive 1. Oh, yes, the first one was -0.5. Thank you. And so now for technical support, I would just like to know what the square root of 2 over 2 is as a decimal. So 0.7 is going to be definitely, as close as I'm going to get. So 0.7, and what's the square root of 3 over 2? Yes, thank you. So 0.87, do point, oh, 8.86, do I, 0.9, I think is as close as I'm going to get for that. Okay, so now when we label our x-axis is going to go from what to what? X-axis, look at it. Negative 1 to 1. And our y-axis is going to go from where to where? Okay, so how are we going to do the negative pi over 2 to pi over 2? Because I have things that are like pi over 4, pi over 6. Oh, I'm going to use the pi. 6 cubbies for pi or 6 cubbies for pi over 2? Got it. Okay, so, oh, and I didn't say from negative 1 to 1, maybe 4 boxes to negative 1? Is that 1, 2, 3, 4? There's negative 1, negative 0.5, 0, 0.5, and 1, because those are all values we use. And then 6 cubbies for pi over 2. So, 3 cubbies is pi over 4, is that correct? Yes? Or no? Well, no. We need to know that. Yeah, we do. So half of that. Then what would pi over 6 be? Pi over 6. So that would be 1, 2, 3, 4, 5, 6. That would be pi then. So 1/6, 2/6, 3/6, right? Or not? Okay, so I'm just going to put a mark here. That is 1/6, right? And what is 2/6? That's really a fraction. 1/3. So that's pi over 6 and pi over 3. And I'm just giving them a little mark, but I'm not writing a number because, I have enough numbers on here, I feel like. Oh, thank you. Okay, so I can't see the graph, so you have to help me a little bit. And let's kind of see what we've got. At negative 1, where am I? Negative pi over 2. At negative 0.9, I'm where? And pi over 3 we said is this one. So negative pi over 3 is at, that's as close as I'm going to get. What's our next decimal? Negative point. Negative 0.7. So there's a half. That's 0.75, right? So it's going to be close to that. Where am I then? Negative pi over 4. I'm just going to put it on that one. That's pretty close. At negative a half, I'm what? Negative pi over 6. At 0, I'm 0. And then I just do the same thing kind of backwards. So at 1/2, I'm at pi over 6. At, what's that next decimal? Those I just don't know. 0.7. So at 0.7, I'm at pi over 4. 0.9, I think it was. I'm at pi over 3. And 1, I'm at pi over 2. And it is that, curve as we go. So it's like this trig curve that's kind of going like that. And I missed a bunch of things. But you will be expected to be able to graph that as you go, and we're using kind of those key points. Now, the next thing we're going to do is we're going to define all the other trig functions, and we just include sine again in that when we write our next little thing, just to kind of let you know. But first we'll visit about cosine. Ready? Okay. Other inverse trig functions is this next part. And so I'm just going to remind you like of the three main trig functions that we've used. So we just looked at sine and kind of go back that way. Here's cosine, here's tangent. I missed it a little bit, but that's okay. So for the inverse sine, we went from negative pi over 2 to pi over 2, correct? Because we could get that from the maximum to the minimum without having any overlap. And it will pass the vertical and horizontal line test. So for cosine, we can start right there at 0, 1, and we can go right down to the bottom. And where am I right there? That's a half of a period. Where am I? Just pi. We're at pi. Because remember, the full period is at 2 pi, and so this is at pi. So for cosine, we get one from a maximum to a minimum from 0 to pi. So then our angles are going to go from 0 to pi. We're not going to use negative angles ever. And when we get our reference angle, if it's positive, it'll be in that first quadrant. But if it's negative, it's got to be that the bigger angle. So those are a little trickier to find. For tangent, look at that. We get one full cycle, which is actually the real numbers, correct? Between negative pi over 2 and pi over 2. But is it defined at negative pi over 2 or pi over 2? It is not. So we're not going to include those as we go through this. But excuse me, we'll start looking at cosine just like we did for sine, and then we'll kind of look at all of them together. So first, just look at these slides and we'll kind of talk about some things. We just said this. So now we get all of our values, and by the way, the ratios go from positive 1 to negative 1, just like before. So that's going to be from negative 1 to positive 1. That'll be our domain. Our range, our angles go from 0 to pi, and it is decreasing in that whole interval, and it is 1 to 1 in that interval. And so that's how we're going to be able to get that inverse cosine. So it's called the arc cosine or the inverse cosine, and it looks like this. Again, the tangent is going to have the same kind of thing. The inverse tangent is going to go from negative pi over 2 to pi over 2. So it's more like sine in that it's either the positive angle or the negative angle. So sine and tangent are actually a little easier sometimes than cosine. And but they are not included, right? Because tangent has those asymptotes at negative pi over 2 and pi over 2. So now we're going to define all of these. And so sine, you decide if you're going to write it again or not. But here it is. So y equals the arcsine of x if and only if the sine of y equals x. The domain, and you know, we've already said the domain goes from negative 1 to 1. The range for sine, negative pi over 2 to pi over 2. If we give that interval notation. Arc cosine, the exact same domain and range, or domain, excuse me, the exact same domain, but now the range for this one goes from 0 to pi. And so that we're going to handle in a little different way. And next to these, I'm actually going to do the 4 quadrants. That's what this is showing us. All students take calculus, all students take calculus, and all students take calculus. So for the sign, we know we use the first quadrant and the fourth quadrant only. So that's the easiest. We find our reference angle. If the ratio is positive, the angle is positive. If the ratio is negative, the angle is negative. But for arc cosine, it's a little harder because we go from 0 to pi. So for arc cosine, if it's positive, it'll just be that reference angle. Do you agree? But if it's negative, we have to use that reference angle, look way over here, and then to find the actual angle, we have to take pi minus the reference angle. So that one's a little bit more difficult, and so we'll just have to be aware of that. And then arc tangent, the domain is actually from negative infinity to infinity, so it includes everything. And the range is restricted. It is negative pi over 2 to pi over 2, but it doesn't include that axis. We can't or the values at negative pi over 2, it's undefined, and at positive pi over 2, it's undefined. So the range for arc cosine is 0 to pi, including those. The range for arc tangent is negative pi over 2 to pi over 2. And it's not including those, just to kind of be aware of that as we go. So here are the pictures of those graphs, and I don't know that you might just sketch the other two right now, and just so the x-axis is still negative 1 to 1, but now we go from 0 to pi. I would say if you just plotted 3 points and just gave yourself a little sketch of that, it would be good. And then arc tangent actually goes the full from negative infinity to infinity. It has a horizontal asymptote at negative pi over 2 and at positive pi over 2, and it kind of, that kind of is a little deceptive. It kind of looks like that in my mind as you go. And so just so that you have a little visual picture of that one. Okay, so the next thing we want to do is we want to just make our table of values. So I'll pause this a minute and have you generate a table of values, and then I'll write it up there.